Hi guys, welcome to Geeks for Geeks practice. In this video, we will talk about the problem of the day for Monday, which is a stock span problem. Okay, so in this problem, this is basically a financial problem as written, in which we are given a series of n daily prices quotes of for a stock. Okay, so we are given n stocks. Okay, and these are for daily. Okay, so what do we have to find? Let us calculate. So we need to calculate the span of stock price for all n days. So we have to calculate the span. Okay, so what we are given n and daily stocks, let's say we call it as S. Okay, so the span Si or span I am going to write it span I. Okay, so span I is the stock's price on the given day I is defined as the maximum number of consecutive days just before the given day. So for example, if the given day is I, okay, so we have to find the maximum number of what? Consecutive days. So we have to find the maximum number of consecutive days less than equal to I. Just before, sorry, so it should be less than I, and for which the price of the current stock, the price of the current stock is less than or equal to the price on the given day. So this means all the stocks, for example, we are at ith position, then all the stocks less than I, we have to count the maximum such that this stock of I is greater than uh, equal to some previous stock, let's say J. Okay, so what it is saying that if I scroll down, so if I say it right, if I am given what, I am given a n stocks. Okay, and I have to calculate the span. Span is basically the span of I says that span of I, right? Span of I says that we have to find the maximum count for all values before n. For all values before n, before I less than equal to I, such that S of I is greater than S of J. For all values greater than, for example, if we have 1, 2, 3, 4, okay, for fourth, this part, right? Since it is greater than 3, right? It is greater than 2, it is greater than 1. So the answer for this will be come out to be 3, right? So it is going to be 3. So let us take some other example. If I take uh, n equal to 4, and my this stocks are 5, 2, 3 and 4. Okay, so I have to calculate the span of 4. Span of 4 I am going to calculate. So for this, what do I have to do? I have to move from just before the 4, just before I have to move, right? So if I move from here, I see that 4 is greater than 3. This means it is true. So my count has been increased to 1. Initially it was 0. Now it has increased to 1, right? And then I come over to 2. Okay, so my 2 is also less than 4. So this is also true. I will come over to this. Now come over here. When it was true, now my count will increase to 2. Then I come over to 5. Is this true? No, it is not true. This is false. If it is false, the count needs to increase. No, count is not equal to 3, but the count remains 2 over here. Also, we have to also include the ith position. So the count will be not equal to 2. Instead, it will be 3. These 3 elements will be counted for a span of 4. The span of 4 will contain 2, 3 and 4, therefore the count is 3, and we will have to print that. Okay, so let us take the example given in the problem. So we are given okay, so what we are given, 100, 80, 60, 70, right, and we have 65. So 60, 70, 60, 75, 85. 60, 75, 55. So this is right. It is it. Okay. Okay. So this is the array given to us, or the stocks. This is the stocks. So it has n equal to 1, 2, 3, 4, 5, 6, 7. So n equal to 7 is there. And we have to find the answer for each of these. Okay. When I come over to 100, what I will see that there is nothing present before this. So answer for this is always going to be 1. For the first position, for I equal to 1, it is going to be 1. Always answer is going to be 1. So span of I is always 1. Okay. So when I come over to 80, I see that when I move from here to here, I see that 100 is present. So the answer, since 100 is greater than 80, right? But we want 80 to be greater than 100. So this is not true. This means it is also 1. It includes 80 only. So when I come over to 60, I see that 80 is greater than 60, right? So I will again break over here and write 1 over here. Now I will come over 70. What will happen? I will move from here. I see that now 60 is less than 70, right? My 60 is less than 70. Okay, so means the count has been increased to 1 by 1. This means the count has been increased to 2 now. Okay, now I move ahead. I see that 80 is greater than 70 now. We need all elements to be less than equal to stock I. Right, but 80 is greater. This means we don't have to increase it. So the final answer for this is going to be 2. Now when I come over to 60, I see that 70 is greater than 60, right? We have to move from just before I. Okay, so just before I, my pointer is here. So when I move from here to here, I see that 70 is greater than 60. So I am not going to move ahead because the just previous element is going to be over, right? So the answer for this is again 1. So when I come over to 75, I see that 60 is present, then 70 is present, then 60 is present, right? So these 3 elements are present which are less than 75. And we need continuity. So what we need, less than equal to I, and we need continuous in what? We need continuous such that the stock of I is greater than equal to stock of J, right? So we want this element to be greater than its previous. So only 3 elements are there. So if I include this also, it is going to be 4. For this, I see that from here to till here, all the elements are less than equal to 85. This means 1, 2, 3, 4, 5 is there, and a 6 is also there. So the answer for this is going to be 1, 2, 1, 1, 1, 2, 1, 4, 5, 6. Okay, so this is our final answer for this question. So this is span array, and we need to find this array. So how to do this? So we can use first use a brute force approach, right? I should also tell you on the next page, or by erasing this, the same page. Okay, so it is going to be so now we need to use a brute force approach. Okay, so what does the brute force approach say is that since we have to calculate from the I minus 1 to 0th position, right? We have to move from I minus 1 to 0 position. This means if I come over to I will check from I minus 1 to 0, and as soon as I found that my S of I is getting, Sj is getting bigger than S of I, then I will break it, right? So what I am doing is first move from, for 0 to I or 0 to n, I will be moving from here to here, and for each of them I can move from n minus 1 to I, n minus 1 to 0, right? I can move from n minus 1 to 0. I can move from n minus 1 to 0, right? So for this, what will happen if the price, instead of price, I am going to write, let's say it is price, right, or the stock. So if the price of I is less than price of j, for such case we are going to break, right? Initially the count has been become to 1, okay, and otherwise if it is not, I'm going to increase the count. C++ is going to be there, okay? So here the count was 1, now the count has been increased. So when I come over to 100, I see that there is no element present before this, so it will not go into this and print the count, and the final answer for 1 I will get will be 1 only, right? For 80, I will be moving from here. I see that my price of j is this is greater than this, so I will break this and the count remains 1. Now I come over to 60, same thing will happen and the count remains 1. Now when I come over to 70, I will see that my price of j now is less than price of I, so I will come over here and increase my count. So my count for 70 will increase from 1 to 2. Okay, now I will go ahead. So I will move ahead from n minus 1 to 0. So I will go ahead, but see that my 80 is present, which is greater than this. So I will not move to 80 again. Instead, I will break it over here, because this thing will come true. So this will become true. If this becomes true, then I am going to move ahead and so on, and I will be getting my answer 1, 4, and 6. So is this clear to you? So I think this is all clear to you. This was not a big issue, but there is something I need to tell you about the brute force approach. Okay, so when I tell you about the brute force approach, let us calculate the time complexity for this. Okay, so let me calculate the time complexity. So if I calculate its time complexity, what I will see that brute force approach, for first we have a loop from 0 to n, then we have a loop from I minus 1 to 0. So in worst case scenario, it is going to be O of n square, as we are moving from this to this, and if the break doesn't work at every position, right? When the break will not work when the arrays are equal. So for this I will be checking over here. For this I am checking in both of these. For this I am checking in all of these, right? So for final array I am checking in, for final value I am checking in all the array. So the time complexity is going to n square, right? But our n is lying between 1 to 10 raised to the power 5. So such big values, do you think it is going to work? No, it is simply not going to work, because for such big values, these things doesn't work, right? So for such big values, these things doesn't work. So we need some efficient approach. But before that, I am going to also calculate the time complexity. The space complexity. So the space complexity for it is going to be O1. Why it is O1? Since we are not using extra space. No extra space is there. No extra space. So the space complexity is going to be O1. So I think this is clear to you. So now we will be writing the efficient approach. Okay, so we are going to write this. So what to do for an efficient approach? But I can think of an efficient approach is that we had this 100, 80, 60, 70, 60, 75 and 85, right? We had this. So when I come over to 100, right, I have to check it from here. If I get a value, right, if I get a value that is greater than this value, right, for example, let me tell you, for example, for before that, before 100, I have something, let's say 1000 is present, right, and all of these values before this are going to be less than 100. So for example, if I take this 85, okay, if I take this 85, what will happen? When I am taking this 85, I see that only 100 is a bigger value, greater than 85, and which is present to the left of it. To the left of it, it is present, and therefore all the values that are present in between them is going to be present in the count. It is going to be present in the count, right? So all these values, C plus is equal to all these values between 85 and 100. If I move to left, right, this means for 80 it is going to be present over here, for 60 it is going to be present over here, for 70 it is going to be present over here. So instead of checking the least value, if I check the highest value present just before this, if I check highest value present, highest value greater than value greater than price of I is present just before I. Okay, so we need highest value that is present just before I. Then we are going to put that position, let's say that position name is J, so the answer will be I minus J. Count will be increased from for example, this is a J and this is I, right, and the element between them is 1 2 3 4 5, and if I include this it is going to be 6. So if I put I minus J, since J is equal to 0 and I is equal to 6, so if I put I minus J, it is going to give me answer 6, right? So my answer is going to be 6, right? So what I am telling is I have 100, 80, 60, 70, 60, 75, 85 and 100. Oh, and nothing. Okay, so it is getting over. So what I have to calculate, value just greater than equal to price of I. Now do you think it is some of the similar problems we have covered so far? It is basically greater next element, or in this case it is going to be previous element, greater previous element, in which we have to find the greater value greater than equal to price of I. So it is a just greater than equal to price of I and present just before I. Okay, it should be less than I. So present it, and we have to print their position. And okay, so for such value, for such thing we use a stack, right? It is obvious that we are going to use a stack and keeping all of them in a stack. So how to use a stack? I am going to tell you how we are going to use a stack. So I will be having the stack over here, right? And I had 100, 80, 60, 70, 60. Oh, sorry. This is going to be 75 and 85. Okay, so since the stack is empty, I'm going to push it. So 100 is there, and the answer for this is going to be 1. Okay, so now for this stack is empty, so our answer is going to be 1. For 80, I see that 100 is present, means 100 is uh, greater than the value, or instead of 100, if I keep its index. Okay, so if I keep it in index, I see that my 100 is greater than 80. So this means that my j is equal to 0. This part, my j is equal to 0. So now I will put I minus j. This means the stack is not empty and all the elements between these are going to be included. This means it is going to be 1 minus 0. So the answer for this is also 1. Okay, for 60, when I come over here, before that I am going to push 80 and 1 will come over here, right? So what will happen now? 60 is there. 60 sees that 80 is present, which is greater than 60. So it will be doing I minus j. So my j is 1 at the top of the stack. So it is going to be 2 minus 1. So it is also going to be 1. Now I will push 60 with the index 2. So I have 70. What I will see that my 70 minus 2, this 70 is at position 3, while 60 is at position 2, right? Over here, the top of the stack. So I see that my 60 is less than this. My 60 is less than 70. So I move on by popping it from the stack, right? In the next, in the previous greater element, what we do? We put it out of the stack. Why we put it out of the stack? We want such a value which is greater than the current value in the stack. Okay, now I will come over to 80. I see that it is greater than this 70. It is greater than 70. Okay, so when it is greater than 70, I will put I minus j. So 4 minus 2 will be there. So the answer for that will be 2. Okay, for 70 it is 2. For 60 now I have come, and before that I will be pushing 70. 70 is pushed with the value 4. I see that it is going to be 1. For 75, when I calculate, 60 will be pushed in. So my stack will be like this. So my 100 is present with the value 0. 80 is present with the value 1. Now my 70 is there with the value 4. Now I insert 60. I insert 60, which has a value of 5, right? So I see that my 75 is greater than this. Pop. Again, pop. Now I come over here. I see that my 75 is not greater than this. Okay, so what I will do? I will put I minus j. So I is present at 5th position. I is present at 5th position, and my j is at 1. So I will be doing 5 minus 1. So it will come out to be 4. So it is 4. And when I come over to 85, okay, when I come over to 85, what will happen? My stack is like 100 out of 0, 100, 0, 81, right? And then I have 75 and 5. Okay, now when I come over to 85, I come over here, I see that this is low. So pop it up. Again, this is low. So pop it up. Now I will come over here, right? I see that my 100 is greater than 85. So if such thing happen, I'm not going to pop up, and instead I'm going to break it up, right? Break over here and put value I minus j. So it is going to be, means all the elements between 100 and 85 are going to be included, right? So it is going to be I minus j. So the answer for this is going to be 6 minus 0. It is going to be 6. So I have got my answer, and this was the answer we were also getting earlier. So I think this is clear to you. So we will also calculate time complexity. So since we are using the stack, and we know that time complexity of it is going to be O(n), because each time we are processing it once, and in the stack, since we are maintaining a stack, it is also going to be like 2 or 3 times, or more than that, something more than that, which means it is going to be O of 2n or O of 3n. but all of these are nearly equal to O of n. So finally I am going to write that my time complexity is O of n. Okay, so I think this is clear to you. As we are using stacks, so my space complexity is all going to be O of n also, because it might be possible that my stack goes full up, right? It goes full up. So stack is created with the so it can have a O of n complexity. So now I will going to write the code for this. So let me write the code for this. Change my screen. So I think my screen is visible to you. I will write the code for this. Okay, so I am keeping the stack. So I will be keeping the stack. I am also keeping the vector final. I have to print the span vector. So I will be writing span. So for initial value, I am going to put 1, and stack will be pushed with the value price or the index. I will be putting it with the index. Okay. Okay. So I think this is clear. So now I will be starting from I from 1 to n, and if what I will be doing while stack is not empty. And price of st.top is greater than equal to price of I. Okay, oh sorry, this should be less than equal to I. Okay, so if it is so, I am going to pop the stack. Okay, otherwise what I will be doing, if a stack is empty, means all the values are less than I, right? All the values are less than I means all of this is true, and we are putting s dot pop. So the answer will be 1. Answer will be pushed with 1, or I plus 1. I should write I plus 1. Otherwise, it is going to be I minus j, right? We were doing I minus j, so it is going to be I minus s dot top, and finally inserting the current element. Okay, and finally returning span. So now I will be compiling my code and check if I am getting the right answer. Okay, so there is some error. So it should be st.push, and it should be st also. This should be st. Span.push back it is. What is the problem with this? It is saying that span I is not present. At what? Here. So it should be one. So now I will be compiling the code, and it will be giving me the right answer. Okay, so it is giving me the right answer for this. So I have done the drag errand for this in the explanation. So I think it is all easier to you. We have to find the greater previous element. Okay, greater previous element we have to find. So I think this is clear. So now I will submit the code. Okay. So I think it should give the right answer. So yes, it is giving the right answer, as you can see. So I think this is over now. So thank you all for joining, and please subscribe the channel, and if you like this video, please hit the like button. Thank you guys.